Exponential functions are in the form of f of x equals ab raised to the x, where a is the initial value and b is the constant percent change. When writing an exponential function given 2 points, you want to find either a or b. Typically, a is the easiest to find because of the fact that if you have an ordered pair of 0, a number, that y value is your a, is your initial value. Once you find that, then you can just take the other point that you're given to find b, and from there just plug in a and b to find your equation. However, if you can't find a or b off the bat, you need to write a system of equations to be able to find a and b, which is what this is going to be. We have the ordered pair -2, 6 and the ordered pair 2, 1. Neither of them have a 0 for an x value, so we don't have an initial value starting off. So we don't know anything about it. So what we're going to do is remember that the form is y equals ab to the x. I'm just changing it from f of x to y. And then if we don't know a and b, we're going to have to take each ordered pair and plug it in for x and y so we can write a system of equations. So for the first one, x is -2 and y is 6. So for my first equation, I'm going to get 6 equals ab to the -2. And then for the second order pair, 2 is x and 1 is y. So I'm going to have the equation 1 equals ab squared. Now you need to solve for a on one of them, and it doesn't matter which, both will give you the same answer. But I'm going to choose this one for a couple of reasons, and you're going to see why. To solve for a, I'm going to divide the b raised to the -2 over. So when I do that, I'm going to get 6 over b to the -2 equals a. And now here are my reasons. I have a fraction, but I also have negative exponents. So if I take this negative exponent and move it up, I'm going to end up with 6b squared because the exponent power is going to change from a negative to a positive. So now I'm going from a fraction with negative exponents to no fraction with positive exponents. So it makes it a little bit easier to work with. Now, because I know what a equals, 6b squared, I'm going to plug it in to the other equation for a here. So I'm going to get 1 equals 6b squared times b squared. Distribute the b squared inside. I'm going to get 1 equals 6b to the 4th. And now I just need to solve for b. Divide the 6 over. So quarantine that off a little bit. 1 over 6 equals b to the 4th. And now I got to solve for b because it's to the 4th power. I'm going to need to take the 4th root. And now because it's an even index, you need to have plus or minus. But remember, b has to be a positive number, so you can discard the negative in this case. You only need the positive. So what is the 4th root of 1/6? Haven't a clue. So what you're going to need to do is you're going to plug it into your calculator. And I'm going to round it to 6 decimals just so I can get it as accurate as possible. But when you put this into your calculator, you should get 0.638943. And that is my b value. Now I got to get a. So I can take what b equals and I can plug it into one of the original 2 equations started off with. Or I could go with what a is equal to down here when I manipulated the first equation. I'm going to use this because it's already solved for a. It makes life easier. But if you want to use one of the original 2, it'll work just fine. Just a little bit more work. So I'm going to get 6 times 0.638943 squared equals a. Now again, what is all this? Haven't a clue. You can do it by hand, but that's just going to take an awful long time. So just throw this into a calculator and see what you come up with. And what you should come up with, rounded to 6 decimal places again, should be 2.449489. So that is your a value. So we have a, we have b, and now we can plug it into our form here, y equals ab to the x. So our answer is, and I'm going to write it as function notation, f of x equals a, which is 2.449489 times b, 0.638943 raised to the x power. And this is the exponential function from these two ordered pairs.